Hey folks, welcome to the first video in the P4 topic, which is all about atomic structure and radiation, radioactivity, half-life, all that good stuff. So we're just going to jump straight into it. So we're going to start off with some basics. The first one is atomic structure. So you can see here the outcomes are to describe the structure of the atom and to calculate numbers of protons, neutrons, and electrons. You've probably done a little bit about the structure of the atom before. It does you no harm to go over it again though. So there's some key words down at the bottom. We've got atomic number, ionize, mass number, nucleon, proton, neutron, and electron. And all I want you to do to start off with is just to draw, just from memory if you can, what you think an atom looks like. It says in your book, do it on a piece of paper or wherever you want to do it basically. Once you've drawn it, can you label any of the parts that make up an atom? So just pause the video, don't spend more than 60 seconds doing it, quick little diagram, and then I'll show you a diagram of an atom in a minute and you can see if you've got any bits right or what you've got wrong. Okay, so let's move on then. So before I get to a picture of an atom, I just want to talk about something called relative atomic mass. We're dealing with some pretty difficult things to wrap your head around here. We talk about things that are so small, they're obviously not visible, but they're also, it's not possible to measure them in terms of normal units of mass that we'd normally use. So let's jump straight into it. So atoms are small. Because of this, they can't be measured in grams, so we use what's called atomic mass units. The atoms of each element all have what's called a relative atomic mass, or RAM or RAM, and it's the mass of one atom of the element. So we're not talking about, when we talk about relative atomic mass, which we might talk about later on, I don't mean, if I say it's got a relative atomic mass of like 12, I don't mean it weighs 12 grams or 12 kilograms, because those units are way, way too big to measure the mass of an atom. So we use what's called relative atomic mass instead. Think of it like a unit that we use just for measuring the mass of atoms. Because obviously they're really small. It's like a comparative unit, basically. This is quite interesting here in this key information section. The radius of an atom is about 10 to the power of minus 10 meters. It would take around 5 million of them placed side by side to cover the distance of 1 millimeter. If you've got a ruler nearby, just have a look how big 1 millimeter is. And think about in that amount of space, you could fit 5 million of them side by side. The radius of the nucleus, so we'll talk about what the nucleus is in a second, but it's the center of the atom essentially. Is less than 1/10,000th of the radius of the atom. So that hopefully that hits home about the scale of the things that we're talking about. They are minuscule. This is what an atom looks like, or I should say, this is our representation of what an atom looks like. Obviously, it's a good model for understanding what's in the atom, even if it doesn't look exactly like this. So there's 3 particles that make up an atom. Hopefully, you've drawn something that looks a little bit like this from the start, so I asked you to just draw from memory, if you could, a quick diagram of an atom. So let's go through what each of these particles is called and some of the properties. So first of all, we've got this. All of these are the same. You can see these green ones with little negative icons on. They're electrons and they are negatively charged. We'll go through the charges and masses of these in a minute, but let's just look at where they're found first of all. So the electrons are negatively charged. The protons, you can see these little plus symbols, the blue ones. Now, they're not really blue, and just like electrons aren't really green, and the next particle I'm going to talk about isn't really red, we're just using those colours to be able to differentiate between them on this PowerPoint. They're not really different colours. So these are protons, and they are positively charged. And then finally, we've got neutrons, and they don't have a charge at all. So you can see there isn't a charge symbol on there because they're not positive and they're not negative. They don't have a charge. Overall, they are just neutral. So protons and neutrons sometimes are called nucleons as well, as in these are the nucleons because they exist in the nucleus of an atom. The electrons are spread out around the outside of the nucleus. They orbit, and these lines, again, these lines don't exist. They are giving you an indication of where they would orbit around a nucleus. Think of it a bit like planets orbiting around the sun. You've probably seen a diagram that shows you Mercury, Venus, Earth, Mars, and so on, and big circles around the sun. Now, those circles don't really exist, just like they don't really exist in an atom. It's just showing you the path that might take around the thing that it's orbiting. So the protons and neutrons exist in a really dense core at the center of the atom, and this is called the nucleus. So later on, when we talk about earlier on when we were talking about the nucleus being 1/10,000th of the size of the actual radius of the atom, that's what we're talking about. So you can see the atom could be this big, and then the nucleus itself resides in a minuscule little portion right at the center of it. So you could realistically say that actually atoms are made up of mostly nothing, just empty space. Massive distances between, or I should say relatively massive differences between the particles that make up an atom. You might hear these called subatomic particles as well. Subatomic just meaning below the size of an atom, which makes sense because if these are the particles making up an atom, of course they must be smaller than the atom itself. Okay, so subatomic particles is the name for any of these. So a proton, a neutron, an electron, they're all subatomic particles. These two in the middle, protons and neutrons, sometimes called nucleons, and then obviously the electrons orbit around the nucleus in layers called shells. So let's have a look at these subatomic particles in a bit more detail then. So you can see the headers of this table. We've got the name of the particles, so the three that we're interested in are protons, neutrons, and electrons. And we've got mass and we've got charge. So we want to talk about mass and charge. Now, the same problem exists with subatomic particles as it does with atoms. We can't talk about them in terms of like grams or kilograms or micrograms or whatever. All those units are way, way too big to measure these. So the numbers that I'm about to show you on here for mass are just comparatively. So let's just have a quick look at them and I'll explain that in a bit more detail. Protons have a mass of 1 and neutrons have a mass of 1. Now, again, that doesn't mean 1 gram or anything like that. What it means is if you could hold one, if you could actually feel it, if you held a proton in one hand and a neutron in the other, the mass would feel about the same. They're the same. Even if you can't measure them, we can still say, oh, they have the same mass. An electron at the bottom there, you can see it says almost 0. The actual number, if you wanted a number there, I think off the top of my head, is 0 comparatively. So if they're both 1, electrons would be something like 0.0005 in comparison relative to the other two, proton and neutron. So the mass is minuscule compared to protons and neutrons. Let's have a look at the charges. And by charge, I mean, is it positive? Is it negative? What's going on? So a proton has a +1 charge, as in it's positive by 1. A neutron has no charge at all. It's completely neutral. And then an electron is -1. It's got a -1 charge. So 1 negative charge. Now, this is pretty interesting because if you think about this, if I had an atom that was made up of 1 proton and 1 neutron and 1 electron, then the actual charge overall of that atom would be 0. Like if I've got a positive charge here and a negative charge here, if I add them together in one big atom, those two things cancel each other out essentially. So overall, that atom doesn't have a charge. That's the same for every atom on the periodic table. No atom on the periodic table has a charge. If you did end up having an atom with a charge, because I don't mean to confuse you, but they kind of do exist. But as soon as an atom gets a charge, it's no longer called an atom. It gets a new name and it's called an ion. And ions could be positive or negative, and we'll get into that in a later lesson when we talk about radioactivity. So let's have a look at an atom in particular. So the atoms of any particular element always contain the same number of protons. For example, carbon. So there's carbon, and there's a couple of numbers on there. You've probably seen something like this on the periodic table before. So carbon's got 6 protons, and this is known as its atomic number. So you can see here, this number at the bottom, 6, is its atomic number. So what does that actually mean? An element's atomic number is always the smallest number of the two. So here at the top, it said atoms of any particular element always contain the same number of protons. The proton number here, or the atomic number as it's also known, is 6, meaning if I was to give you one atom of carbon right now and say, oh, could you just take the protons out of that for me? You'd end up with 6 protons because it always contains the same thing. A good way to think about this is the number of protons is what basically determines what the atom is. So if I gave you 6 protons, you'd have to be able to make an atom of carbon out of it. You take a proton out, you've no longer got carbon, you've got a different element. And if you wanted to, you could have a look at the periodic table and find something that's got an atomic number of 5, and you'll figure out what it is that you've just made. If you were to add protons to something, you'd end up again with a different element. So the number of protons basically determines what that element is. What's the atomic number of these elements then? So just have a quick pause of the video and just have a look. I kind of skipped over that last bit. I'm just going to show it again. Have a look there and then go back to that. Just pause the video. What is the atomic number of these elements? Just pause it. Okay, so let's have a look. So first of all, we've got sodium up here. We've got 2 numbers, 23 and 11. But this pink box here said an element's atomic number is always the smallest number of the two. So here we've got 11. Its atomic number is 11. So sodium has 11 protons. Iron, 26. So it's got 26 protons. Tin, we've got 50 protons, smallest of the 2 numbers. And then fluorine, we've got 9 protons, again, smallest of the 2 numbers. Now, you're probably thinking by now, what are these big numbers? We'll get to that in a second. So all you need to worry about so far is the atomic number, is how many protons it's got, and it's always the smallest of the 2 numbers on the periodic table. Don't get into your head that it's always the number at the bottom, because that's not true. Depending on which periodic table you're looking at, some of them have the atomic number at the top, some of them have the atomic number at the bottom. I think I've got one in my room where the atomic number's on the side. So ignore its position. It's not about its position. It's about which number for that atom on that periodic table that you're using is the smallest, because that's its atomic number. Okay, so we've talked about the particles that make up atoms, and we've talked about how to figure out what the number of protons is looking at it. If you're given a couple of numbers, which one is the atomic number? You need to know how to work out how many neutrons there are in an atom as well, though. And to figure that out, this is what's known as the mass number minus the atomic number and that will tell you the number of neutrons. And I'm just going to skip back a few just to show you what I'm on about here. So mass number minus atomic number. So let's just go back to this. The mass number is the number of protons and neutrons in an atom. Basically, it's all the particles added together that have mass. And I know I'm kind of going against what I've just said a second ago, that electrons have a tiny mass. It's so tiny, it's not even included in the mass number. Okay, so it's number of protons and neutrons is the mass number. So if we have a quick look at this, the mass number would be, well, how many protons have I got? 1, 2, 3, 4, plus the number of neutrons. So 5, 6, 7, 8, 9. So the mass number of this atom here would be 9. It's got an atomic mass of 9, meaning all the particles have mass. If you added them all up, the mass is 9. Now, if I went back again down here, let's just have a quick look at what that equation was. Mass number minus atomic number, so 9 minus the number of protons will tell you how many neutrons there are. So let's just go back. So it was 9 minus the number of protons. So 9 minus 4 equals 5. So the number of neutrons in this atom is 5. And that kind of makes sense. If I said I've got a bag containing 10 pieces of fruit, 10 apples and pears, and I've got 4 apples, how many pears have I got? Off the top of your head, you could just straight away, you can go, all right, if you've got 10 altogether and 4 of them are apples, the other 6 must be pears. It's the same situation here. The mass number is how many have you got altogether. The atomic number is how many protons there are. Well, if you take the number of protons out of how many there are altogether, whatever's left must be neutrons. Okay, so that's how we're working that out. Find where I was again. Okay, so having a look at this then, you can just pause this for a second. I want you to try and figure out what the number of neutrons is for each of these atoms. Okay, now it's not, in fact, I'm not even going to tell you. I'll go through the answers in a second and then I'll tell you. Okay, so just pause it and give that a go. Okay, so let's have a quick look at this then. So the mass number of helium is 4. So in terms of protons and neutrons, it's got 4, and the atomic number is 2, as in it's got 2 protons. So if I've got 4 neutrons and protons, and I take 2 protons out of it, the 2 protons out of it, I should say, I'm left with, well, 2, aren't I? Okay, here are the answers for the others. 19 mass for fluorine, as in 19 protons and neutrons, minus 9 protons gives you 10 neutrons. Now, I will say that it's quite common on the periodic table, or with atoms, I should say, for the mass number and the atomic number to be close to each other, as in you can see there it's 4 minus 2 equals 2. It's not always split down the middle. Okay, it doesn't work like that, and fluorine's a perfect example there. There's more neutrons than there is protons in fluorine, so don't think it's always, if it's got 5 protons it's got 5 neutrons, because that's not the case. In some things it is, but not in everything. So you just need to remember that mass number minus atomic number gives you the number of neutrons. Right, so let's just have a quick go at these quick check questions. Again, pause it for me. Number 1 says a radium atom has 88 protons and 226 neutrons. How many electrons does it have? And then question 2 says a uranium atom has 92 electrons and 238 nucleons. Determine how many protons and neutrons it has. Now, I'm aware I've given you 2 questions here that are going to involve you having to think about the atom that we drew earlier on. I've intentionally missed something out to get you thinking about the next step. So just pause it and see if you can do it without my intervention, and then we'll go through the answers. Okay, so let's go through the answers then. So number 1, a radium atom has 88 protons and 226 neutrons. How many electrons does it have? Well, the answer is 88, because atoms have got the same number of electrons as protons. Now, if you want to rewind the video, I won't go back again because it's getting a bit confusing. But if you want to rewind the video and go and have a look at the atom that I showed you earlier on, if you look at how many protons there are, it's the same as the number of electrons. That is the same for any atom. Okay, I said earlier that every atom on the periodic table is neutral, and that's because they all have the same number of protons as electrons. If that's not the case, they're not atoms, they're ions. So straight away, where it says how many electrons does it have, just if you're given an atomic number or the proton number, it's that. It's always the same. You've been told it's an atom, and you've been told how many protons there are. The electrons number is always going to be the same. So realistically, you didn't need to know how many neutrons there were. It was irrelevant. Number 2 then. A uranium atom has 92 electrons and 238 nucleons. Determine how many protons and neutrons it has. Okay, so you need to be thinking of a few things here. 1, how to figure out how many neutrons there are in a nucleus. So that was atomic mass minus atomic number. But you can't do that without knowing how many protons there are, and you're not given the proton number here. So you have to remember again that the number of electrons is the same as the number of protons. So first of all, we need to say, well, the number of protons is 92, because we've just been told that there's 92 electrons. So straight away, we now know how many electrons there are, how many protons there are, and how many protons and neutrons there are together. So we've got that big number, all the protons and neutrons, and we know how many protons there are, so now it's just a case of one minus the other. So for the neutrons, it's 238, which is the mass, minus 92, which is the number of protons, and that gives you 146. So the number of neutrons is 146, the number of protons is 92. I'm aware that this is probably quite confusing because I'm going through it quite quickly. So rewind it, go through it again, have a look, pause it, write things down. Whatever you can do to make you remember this, because it will come up again and again. Okay, it's a useful bit of information to have. Right, so there's just a quick true or false question here, questions, I should say, that I want you to try. And then after that, I'm going to give you like a worksheet style questions where we go at. So just pause that video, just see what you can make of those, true or false. Right, let's go through them then. So number one, atomic number is the number of neutrons in an atom. False. The atomic number is the number of protons in an atom, not the number of neutrons. An atom is the smallest particle of an element that can exist on its own. That's not true, as you'll find out in the radioactivity lessons that we're going to do when we talk about radiation. Some atoms are unstable and end up ejecting small particles of themselves. Some things give out electrons, for example, they'll fire out an electron to make themselves more stable. So that, and that electron can exist on its own. It just gets farted out and ends up hitting something else. Number three, elements are made up of identical atoms. True. If you've got a pure substance, let's say you managed to get 100% pure gold, every single atom in that substance would be gold. That's what pure means. So elements are made up of identical atoms. True. Number four, there are 4 types of particle in an atom. That is false. There's only 3. So we've got protons, neutrons, and electrons. If you end up doing physics at A level, you'd actually find out that there's some particles that make up the particles that we're talking about today. So protons and neutrons are actually made up of even smaller particles, but that'll just cause some confusion. Just to make you aware, though, there are smaller particles. Okay, so you're not kind of, if you do A level physics, it doesn't just come out of nowhere. Number 5, the number of protons in an atom is the same as the number of electrons. True. So the number of electrons and protons in an atom is the same. That's why we call them atoms, because they're neutral. Atoms are neutral by definition, so they must have the same number of protons as electrons. Number 6, atoms have no electrical charge. Now this is a bit of a tricky question, this, because at first you're thinking, well, protons are positive and electrons are negative. So yeah, of course, that's false, because of course they've got a charge. But it's talking about an atom in its entirety. So one atom, if I give you one atom, is it positive or negative? Well, it's neither, because it's got the same number of protons as electrons. It doesn't have a charge. So the last one's actually false. Right then, so here's some questions. Wait to have a go by yourself. So it'll probably take you, I don't know, 5-10 minutes or something to go through these. Just pause the video and give that a go. There's a few questions there based on what we've said today. By all means, if you don't know an answer to this, go back through the video, see if any of that will help you. If you can't find it in the video, Google it. You've got the internet at your fingertips. So I don't mind you trying to research the answers to this. But I am going to show you the answers in a second anyway. But it's important to try yourself. So just pause it and give those questions a go. Okay, and then your answers are there. Okay, so for the first one, obviously we've got gaps here. These are the words in order. So symbol, number, electrons, relative, protons, equal, isotopes. Now isotopes I've not gone through today, but we will go through those in another lesson, I think. And then for the table down the bottom, what name is it? You're going to need a periodic table for that. Hopefully you use that. I forgot to mention that. But those are the answers there for everything that you need. Hopefully that's useful. If you're confused by any of this, or you've got any questions, or you want any help, speak to the teacher that uploaded this on Google Classroom. They'll be able to help you out. If I see it, I'll help you out as well. But in the first instance, it's going to be whichever teacher has uploaded this for you. You need to ask them for some help. Okay, hopefully that was useful. Bye.